Let us learn the next topic, modular arithmetic. In mathematics, modular arithmetic is a system of arithmetic for integers where numbers wrap around a certain value. Okay, wrap, it is coming again and again in the rotation form. That is only given. It is only given in this modular arithmetic. For example, in a clock, we use numbers 1 to 12 to represent the time period of 24 hours. Am I correct? So after 12, again we are starting this 1, 2, 3, 4. So 12 hours. 12 plus 12, it is 24 hours. 2 times only we are doing. But in the modular arithmetic, how many times we need, we can rotate, we can wrap this numbers again and again. Okay. After 12, we again start from 1 to 3. In this numbers wrap around 1 to 12. That is in the clock for 24 hours. The ideas of modular arithmetic was developed by great German mathematician Carl Friedrich Gauss, who hailed as the prince of mathematicians. Please listen this name, Carl Friedrich Gauss. Okay, he is the prince of mathematicians. Don't forget this name. Okay, yes. So here we are studying about the modular arithmetic. You like a clock. Okay, now you see congruence modulo. Two integers a and b are congruence modulo n if they differ by an integer multiple of n. Okay, if whenever we are telling two numbers are congruent modulo n, we can say that is the difference of the two numbers is the multiple of that same modulo n. Okay, we can study this using an example that you can learn it easily. You see this number 61. 61, when you divide using 7, what do you get? 61 divided by 7. 8 sevens are 56. The remainder 5. Okay, so this 5 only we are writing here. It is the remainder. Understood? After writing this congruent symbol, we are writing as the remainder. That's only how we get. It is mentioned here. 61 minus 5 equal to 56 is divisible by 7. For big numbers, we cannot identify in the subtraction form. When you do the division form, what is the remainder, that you can write it here. Okay, so this subtraction here given a congruent to b mod n, you can write as a minus b equal to k into n. Okay, k into n, k is in any integer, like the same you see here, a minus b, 61 minus 5 equal to 56. 56 means 8 into 7. Okay, 7 is the modulo value here given. 7 is the modulo value. 8 is any integer. Are you clear? Here we have a note. When a positive integer is divided by n, then the possible remainders are 0, 1, 2, 3, etc. n minus 1. Depending on the modulo value, we will get the remainder. Here the modulo is 7, so the reminders you will get as 0 or 1 or 2 or 3 or 4 or 5 or 6. Okay, more than 6 is not possible. Whenever you get 7 as the remainder, that you can consider as the one multiple. Okay, so you will get the remainder 0 again. Like this way you will get in the rotation form. So according to the modulo value, you will get the remainder. Okay, if the modulo is n, you will get the remainder up to n minus 1. If the modulo is 7, you will get the reminders, not sure which one, but you can choose only from that 0 to 6. Are you clear? Now we listen on illustration how to find the modulo value using the diagram. Like a clock, we have a diagram. First of all, you see the modulus value. Since the modulus is 4, our possible reminders are 0, 1, 2, 3. Okay, so using this 0, 1, 2, 3, you have to make a diagram like a clock. Clock means 1 to 12, but here 0, 1, 2, 3. Only this 4 numbers. modulus is 4, so you will have to choose only this reminders, and using the number you make a clock. Then you count using the count in clockwise direction. Okay, this arrow indicates clockwise. We are counting, we are putting the numbers in this direction, so this clockwise direction you count from 1. Okay, so the counting you will start from 1. Here this is 1, 2, 3. Which number we have? 8. Till 8 you have to write 4. Then next number you put a comma and write 5, 6, 7. Next one 8. Okay, so we got the 8 near the remainder 0. Okay, here we get the remainder 0 for this number 8. So we will get 8 is congruent to 0 mod 4. Are you clear? Using the diagram, like this way we can find, but for big numbers it is not easy. For small numbers you understand using the diagram, then big numbers you can do in another way. Okay, now you see for the negative number how it is. The number is minus 5 mod 3. Okay, minus 5 mod 3. Here the modulus value is 3, so the possible remainders are only 0, 1 and 2. Understood? From only 0, 1, 2. So 3 numbers are possible. Using the 3 numbers you make a diagram like a clock. Then since the given number is minus, you have to do the rotation, the counting in the anti-clockwise direction from minus 1. Okay, now you see the diagram. Here the diagram is 0, 1, 2. It is the reminder you put in the correct order, but you start the counting from the anti-clockwise direction from minus 1. So this is minus 1, minus 2, this is minus 3. Okay, next this is minus 4, this is minus 5. Our given number is minus 5. Here the remainder is 1. Okay, here the remainder is 1. So we are getting minus 5 is congruent to 1 mod 3. Are you all clear? Since the given number is negative, you have to start counting in the anti-clockwise direction from minus 1. Okay, so here you have to put minus 1, minus 2, then minus 3, again minus 4, minus 5. Our given number minus 5, so the corresponding remainder is 1. That you can write it here as minus 5 is congruent to 1 mod 3. Are you clear? Next one is connecting Euclid's division lemma and modular arithmetic. Let m and n be integers where m is positive. Then Euclid's division lemma, thus we know the division lemma, it is n equal to mq plus r, where 0 less than r less than m and q is an integer, can be written as n congruent to r mod m. Okay, normally whenever we write the modulo, there we are writing the remainder when you are dividing using the modulus value. Okay, so the same procedure from the in the Euclidean lemma, we have the number n, but we are dividing using m. It is the divisor, that means it is the modulo value, r is the remainder. Okay, don't think about the q here. Here n is the given number, m is the modulo, it is the divisor, then r is the remainder. Okay, so the same we can think of, n is the given number, r is the remainder, modulo value, that is the m. So we can write n is congruent to r mod m. Okay, now see the note, two integers a and b are congruent modulo m, written as a congruent to b modulo m, if they leave the same remainder when divided by m. Okay, with the example I explain this. See 61 minus of minus 2. What is the value 61 minus of minus 2? It is 63. 63 you can write as 9 into 7. Okay, again 5 minus of minus 2. What is the value of 5 minus of minus 2? 5 plus 2, it is 7. That you can write as 1 into 7. Am I correct? Okay, from the first line we can write 63. 61 plus 2 is 63. Okay, congruent to, what is the remainder? Minus 2, sorry, not 63. Here the given number is 61. 61 congruent to minus 2 mod. Here in both these numbers 7 is the common divisor, so mod 7. Like the same 5 is congruent to minus 2 mod 7. Okay, so 61 is congruent to minus 2 mod 7, 5 is congruent to minus 2 mod 7. Understood? The same reminder. Okay, now we can write this, since we are getting same reminder, we can write this is 61 minus 5, 61 is congruent to 5 mod 7. That only the example we learned in the first. 61 is congruent to 5 mod 7. Okay, the example we can write like this way also. Okay, 61 congruent to minus 2 mod 7 and 5 is congruent to minus 2 mod 7. So using the Euclidean division lemma, we can write this together. So 61 is congruent to 5 mod 7. Okay. Here you can see the modulo operations. Normally we are using plus, minus, multiplication or the operations in numbers. The same we can use in the modulo also. We are choosing 4 different integers A, B, C and D. Okay, also M is again another one positive integer. This we will choose for the modulo. Okay, these 4 are the numbers such that A is congruent to B mod M and C is congruent to D mod M. If the 4 numbers are like this with this condition, A congruent to B mod M and C congruent to D mod M, then these 3 conditions will satisfy. If you are adding the left hand side A and C, you will get congruent to B plus D mod M. Modulus values are same, so same modulus. Left hand side you add like the same, right hand side also add. Left hand side you subtract, in the same order you subtract the right hand side also. Left hand side you multiply this then and you multiply the right hand side also. Okay, this is the theorem 5. A plus C is congruent to B plus D mod M. A minus C is congruent to B minus D mod M and A into C is congruent to B multiply D mod M. Since the modulus values are same, this all will satisfy. If the modulus values are different, we cannot write this. Okay, how it is possible? We can verify this using the illustration. Where if 17 is congruent to 4 mod 13 and 42 is congruent to 3 mod 13, what about the value 17 plus 42? It is also congruent to 4 plus 3. It is the right side value. 17 plus 42 is left side. 4 plus 3 is right side. Is congruent to mod 13. Okay. What is the value of 17 plus 42? It is 59. Is congruent to 7 mod 13. Okay. How it is it correct? You can check it by dividing 59 divided by 7. You will get the 59 divided by 13. Here the modulus value is 13. So using 13 we can divide. 13, 5, 4 13s are 52. So remainder 7. It is correct. Okay. Then we can check for the subtraction. 17 minus 42 is congruent to 4 minus 3 mod 13. It is using the theorem we are writing. Is it correct? We can check by the calculation. Okay, what is the value of 17 minus 32? So minus 25 is congruent to 1 mod 13. Okay, is it correct? We can check. See this, here this is a negative number, so by division we cannot do. Now minus 25, when you take this 1 to the right side you will get minus 1. What is the value of minus 25 minus 1? It is minus 26. Okay, so minus 26 is divisible by 13. Understood? Minus 22 into 13 equal to 26. So this value is also correct. Next, third one, it is the multiplication. A into C, 17 into 42 is congruent to 4 into 3 mod 13. Here what is the value of 17 into 13? It is 714. Is congruent to 4 3s are 12 mod 13. So when you divide the 714 using 13, you will get that remainder 12. Okay, that calculation I done here. So from this remainder we can say this value also correct. So this theorem 5 is verified using this congruence values. Okay, next one is theorem 6. It is only the statement, if A congruent to B mod M, then AC, that means multiply using another number. Here only they choose the two numbers A and B. So using another common number, when you multiply both the sides, you have no change in the modulo. Okay, so A into C is congruent to B into C mod M. Like the same addition and subtraction. You can add using the same number in both the side and subtract using the same number in both the side. So A plus C is congruent to B plus C mod M, and A minus C is congruent to B minus C mod M. We can read it as plus or minus for any integer C. Okay. So please learn both the theorem 5 and 6 for doing the sum.